Good morning. My name is Calvin Close. Today, I'm going to share with you our plan how we are going to disrupt completely the way we build prototypes and manufacture parts. Alright, many of us have seen this type of picture. But in real life, how many prototypes are made from just one material? No, they're not. In fact, most prototypes are complex and they are time-consuming to make, they're costly, they're error-prone. And what's the biggest problem with them? They're not true to reality. They don't work. Now, there's many techniques for making prototypes. 3D printing, precision milling, sintering, many different types of prototype techniques. Now, the thing about all of these techniques that we see here is that most of these technologies, there's companies that actually do these particular technologies. Now, what have we just said? When you build a prototype, you need more than just one technology to actually make a prototype. What about if you could do it all in one machine? Now, the multi-prototyping lab that we've developed does it all in one machine. So here is the multi-prototyping lab. This is a real machine that we've already built for the US Army market. It consists of three main things. It's the main machine, it's the gantry. There's a head there which actually moves along the gantry and it picks up some modules. What I'm holding here in my hand is a 3D printing module. In actual fact, it can print two different types of materials in one module. So how does it work? Multi-prototyping lab, the head comes up and picks up this from the park position and moves it over to where the prototype is being made over here and performs this process on the prototyping part. So it can print plastic just like any other 3D machine, but everyone else's machine stops right there. But this machine will literally take this back, put it back in the park position, pick up another module, and actually perform another process on the same part. Now the benefits of that are much faster, you don't need to get operators to move the part from one type of machine to another. It's much more efficient, costs a lot less, and it's far more accurate to leave the part locked in place and actually move the process to the part instead of the other way around. So, here's an example of maybe what a 3D printing machine would do. It makes a prototype. Well, what's wrong with it? It doesn't work. But the multi-prototyping lab can not only print housing, the chuck, the electronics, and even the motor. And what it can do then is assemble the whole thing. Now, the prototype becomes the product. If you can completely make the prototype in a functioning product, as soon as you've designed it, built it, and tested it, you have the product. You just start printing them and you can print out the product. So what is our plan? We've already showed you how our machine, we've already built two of these machines, can do prototyping better. We can do it faster, we can do it cheaper, and we can do it more accurately. But we're not content just to stay where we are. We want to actually move into small-scale part production. But then, we want to go the next step. We want to go into what we call distributed manufacturing. So with distributed manufacturing, you actually have several of these machines, maybe around the country, and you can actually design the part, build it here, and then you can build it in several locations at the same time. Let's take the example about NASA. Say we want a part actually up on the space station. What happens now? We design it, we build the prototype, we test it, and then we schedule a launch to actually to take the real product up to the space station. How do we do it? We design it, we build it, we test it, and if it works, we send the code up to the space station, and we print the part right there. No more waiting. Okay, so where are we? This is where we already have come from. We've already We've already built 2 machines, we've proved the concept, we've tested it, we've delivered 2 machines to the US Army Arctic facility in Picatinny. We've developed 6 key modules and we're developing some more. So what are we asking right now? We're asking for you to invest $500,000 in our company. What is that going to give you? It is going to give us the next generation machine where we can put a robot in the bottom, we can produce a lot more different types of parts, and we've also got a few more modules that we want to produce, which will open a whole bunch of other technologies and industries. The other thing is we want to prove this distributed manufacturing capability. And that will ramp up our company to be able to produce 1 to 3 of these machines a month. Now, we're also considering the possibility in 2016 to actually maybe invest $2 to $10 million, and that will help us to ramp up production even more. So, ladies and gentlemen, I want to invite you to join with us to disrupt the way that we build prototypes and make parts. Thank you. Do you have any questions?
So you had the slide up there when you first started with all the different manufacturing technologies. There was a dozen or so different things. So at first I thought you were going to partner with companies that made those enabling technologies, call it, and then integrate those into your sort of meta machine that kind of combines, uses them all. But then later you talked about building modules yourself. So it wasn't clear, are you going to try to build the best in breed 3D printer, et cetera, or are you going to leverage other companies' technologies?
There's a bit of both because, for example, 3D printing is a well-established technology. Okay, so we basically you go out there like that. That's a 3D printing module. But there's other modules where we're going to be partnering, like the laser sintering and all that. There's people out there that have been doing that for years. So our plan is really to partner with them to actually be able to put their type of technology onto our machine.
Given the volume that you're proposing, don't you see it as a challenge to convince other companies to build specialized products for what you're doing? And what incentive would those partners have to work with them?
Most of the technologies that we're talking about, actually, we don't have to rely on them to actually do. In fact, most of these technologies we're talking about, we've already done the preliminary design for them. There's things like robots and things like that. When we're talking about those, we have to partner with a robotic company and use their APIs to link into our system. But essentially, you buy an existing technology and integrate it into our machine.
Let's see. So, with these various material combinations, are there limits to what you can do, in process? So, can you take 3D printed materials and then just do laser sintering on top of that? And if not, can you talk a little bit about the assembly process?
Well, actually, the assembly process, actually, we can think about it in 2 different ways. We can basically build the parts like we currently do and actually use a technology to put those together. But what we're actually more interested in is where we actually do something like what you're talking about. We actually build a metal part and actually then we can print plastic over the top of it, we can machine it, and then print copper tracks straight on there, pick and place and stick components on there, solder them in, cover it back over with plastic, and you've got the whole component, electronics, everything, all in one part. You no longer have to assemble that together.
In addition, this will have actually robots where we could do an assembly if we needed.
Yeah.
I have a few questions that I'm not sure that you addressed as much as I would like to see. First of all, like intellectual property, I know in the business plan you talked about patents, but they seem slow in coming. And also, what really do you perceive the primary and secondary markets to be?
Maybe I'll let Tom is our technical director.
Address the first part, the IP. Our initial filing was in 2009. We've clarified in 2010. And then in 2012, we have totally included everything we all got here and much more. So that's the exact status of the the IP in the back.
Does it take that long to get
And it takes a long time, and especially with the changes in the way of looking at it. So we're anxious. We're seeing it come soon, but there's been nothing happening. All right, we get, to some degree, I guess I could call it somewhat of a captured market in the military side. This particular development was the result of a need by the Army, especially the armament community, to miniaturize very, very complex systems. And you can have a smart bomb, or where they're going is they'd like to have a smart 22 millimeter bullet. And to be able to do that, you can't. You can't even make it by hand. They ask us to try to do it in separate machines. It can't be done. Every time we take the part out, we move to the next operation, we lose too much accuracy. So that's where this whole idea came from. Keep the part stationary. And so where we're coming from is we see military as a part of it. We hope space is another part of it. But we've already got interest from automotive, from aerospace, Boeing. A lot of educational interest in this as a teaching tool for engineers in terms of how they would understand not just with the prototype processes, but how you actually do manufacturing. So,
I'm just going to dig into that just a little bit more because it was something I was very interested in as well. I don't think anyone disputes the value of 3D technology, 3D printing, additive manufacturing, however you want to categorize these different technologies. I guess my question is, when I look at this and I'm looking for a very scalable vertical, what does your customer look like that can actually support an ROI that an investor would be looking at over the long term? Government contracts, military applications are fantastic for a kickstart and get the push on the swing. But I think as far as commercial applications, where do you see, who is your customer? What part is it that you're making for that customer? And where is that market vertical that provides an investor style return?
no, we are. Where we're coming from is we're not in the business of selling parts. We're in the business of selling machines, and we're in the business of partnering with people developing process modules. So that's what you're really seeing here. This $500,000 is to really build the next generation machine that puts a robot in the base. So now we can, a customer who buys that machine can make very, very intricate parts. And then on top of it, we will have 10 to 12 different modules already done. Now what we're talking about is if there's anything other than that unique, well, we would partner in the development of that module.
You're still talking about time span. My question is, who is that customer? Who is the customer that wants to buy a lot of it?
All right, well, what we've already talked to is we've got a lot of interest on the part of the Army. And let me explain maybe what that is. I mean, what is that business? How many 5.56 bullets does the Army make? $1 billion. Roughly 3 billion items. All right, how many of those would be smart? Perhaps 10%. But now what you're into is, the idea of this is that they change a paradigm. Rather than the Army necessarily setting up a whole facility with a whole lot of machines like this, if these types of machines are across the country, and an R&D facility would develop this type of concept on this machine, that code encrypted could be sent to those machines, and then you've got a production base that's already sitting there and can begin to make those parts because it's already been done at the Army R&D facility. Just that one example, okay? I mean, to me, you probably talk maybe 10,000 off of a machine in a month. All right, but I'm trying to break that down to, all right, if we talked about 3 billion bullets, and we're talking 10% of 300 million, you're talking a phenomenal number of machines. Just that one application, we're talking, I mean, we probably got 60 different types of bullets, and bullets are only one part of this. The automotive we've talked to, Boeing is in, their expectation would be spare parts. I'm sorry. Okay. Spare parts. How do they replace parts? So having that in all their hubs, the ability would be to make that part there. All right.
Thanks so much.